A function is basically a rule, and that rule is going to form a relationship. And sometimes that relationship kind of can be looked at as a machine. For example, if you're going to make $12 an hour, the x that goes in, maybe you work 3 hours, you know that you're going to get $36. If you were to work 3 hours at $12 an hour and your paycheck only showed that you made $20, you know that that rule didn't work. It's got to be a machine. It's going to be predictable value. It's not going to change on you. So in mathematics, the definition is that it's going to pair an x value or an input with exactly one y value. So in this case, if we partner this up, if you worked 3 hours, you knew you were going to get $36. And then the next day, if you worked 3 hours and were only paid $20, this is not a function. These two ordered pairs together do not work together because you were supposed to make $12 an hour. So this 3 hours has to be paired with 36. In the same rule, it cannot be paired with a 20. How do we determine if something is a function? Well, basically, we're going to be looking for this duplicate x value. So if you look up here, this 3 duplicated, but its y was not the same. So it might be 3 is pairing with the $36. So 2 I know would pair with $24. And 1 is going to pair with $12. That's a function. This would not be a function if I had 3 pairing with $36, and then I had 3 pairing with that $20, and my 1 was pairing with 12 because I was making $12 an hour. This is not a function. We knew the rule. It said 3 hours worked is going to be equivalent to $36. You were making $12 per hour. So that's a visual kind of what it's going to look like. So what we like to do is look at this relationship. And the relationship would be, in this case, money is a function of time. Money is a function of time. We would write that money is a function of time, and that time rule is 12 times every hour you work, where x is equal to your hours and y is equal to the amount of money. So we say money is a function of time. In other words, y is a function of x. Y is a function of x. Now, when we look at a picture of this function, we want to use a test to see if the picture is in fact a function. Here is a line. I'm going to look at my x's. I'm going to look at my ordered pairs. This is an x value, it pairs. This is an x value, it has a different partner. This is an x value, and so forth. All of these x's are going to unique places. They are never going to the same place. So we use what we call a vertical line to test that. I take my graph and I draw a vertical line through it. It only intersects my x one time. It only intersects my graph once. It says there's only one x for that output of y. Let's look at another graph. Here's a common graph that we'll be studying later on. If I draw a vertical line and I move that vertical line anywhere on here, I see that this x-coordinate maps to that point. If I move over here, this x-coordinate maps. Never is the x mapped or paired with 2 outputs. Let's try a third graph. Drawing a vertical line. The x-coordinate sitting right here, this x-coordinate pairs with two outputs. Therefore, it is not a function because it has two pairs. If you were to go back and look at the situation with the money, it said you were able to work 3 hours and you paired with $12. And then another time that you worked 3 hours, you did not receive that, this should be $36. You received $36. When you worked 2 hours, you received $24. So you see that they're not overlapping. But as soon as I get into this situation where I work 3 hours and have two different outputs, I work 3 hours, and the first time I received $36, and then the next time I worked 3 hours, I only got $20. Do you see that you really have in this place two different outputs, which is impossible? That means that the rule is not working, therefore it is not a function, because the vertical line hits it more than once. So in this situation, not in a real-world context, but whatever this x value was, right at this spot, it paired with two outputs, therefore not a function.